Hi, everyone, and welcome to today's session. So, when we talk about machine learning at AWS, something that we always say is we want to put machine learning into the hands of every developer. Our session today and for the next 2 days are targeted at developers or customers with little to no experience on artificial intelligence and machine learning. My name is Alpana, and of course, hosting this session with me is my good friend Peter. And if this is your first time meeting us, we are your friendly neighborhood solution architects based in South Africa, and our team looks out for customers all across Africa. How's it, Peter?
Thanks, and hi everyone, welcome. We are here to support you on your AWS journey together. My name is Peter, and this is Getting Started with AI and Machine Learning on AWS. Just to add to what you said, Alpana, this session is on foundations of machine learning. In the next two webinars, tomorrow and the day after, we'll get a little bit deeper into some of these services and also look at how we can use ML to gain insights into our data. For today, we're going to cover a basic overview of how it all works, and I'm hoping to spark your curiosity into ML and, of course, touch on my favorite aspect of ML, our managed AI services at AWS.
And Peter, speaking from my own experience, getting started, it can be somewhat intimidating. We have simple questions like, how do I begin? What can I read up on? What are some basic terminologies? So I'm hoping that today we can try to demystify all of this for you guys, for our audience. We'll cover the what, why, when of AI and ML on AWS. We'll go over the AWS machine learning stack, the different components and specifically the different levels of abstraction of AI ML in AWS. And of course, we'll jump back and forth between actual demonstrations.
So let's dive straight into it and talk about some of those terms. Artificial intelligence and machine learning are widely used today, and rarely do we talk about the explanation of these concepts. Or you've heard these technologies described in a number of ways, so let's take a step back and let's kind of set the level on what they are. So first, artificial intelligence is a way to describe any system that can replicate tasks that previously required human intelligence. Almost always, this is related to some kind of complex decision-making where human judgment would be required. So use cases for AI are looking for probabilistic outcome, which is making a prediction or a decision with a high degree of certainty, similar to human judgment. Machine learning is a subset of AI. Almost all AI systems today are created using machine learning. What happens here is machine learning uses large amounts of data to create and validate decision logic, known as a model. There are some more techniques around ML, like supervised, unsupervised, and reinforcement learning. But for our intro, I'll just touch on deep learning. This is a type of machine learning that uses a technique known as deep neural networks. These systems replicate very much how the human brain functions. So this lets AI systems address more complex use cases than was previously possible. It's the basis for natural language processing, which we'll see in a bit.
And I think something that we can add to that is that the key tools here, it's past data and statistics and the probability theory that I used to build machine learning models and make predictions. And also where traditional business analytics aims at answering questions about past events, machine learning aims at answering questions about the possibilities of future events.
Yeah, precisely. And that's very much what AI and ML is. Alpana, can you take us through the why?
Yeah, definitely. So to try and get an understanding of why we would use AI or ML, I'd like to contrast it with classical programming. So if we have our input, something like purchase history, for example, and we want to, we want to figure out how to get recommendations from here or output from here. So we'll build some rules, if then else statements, for example. So for many of us, we can just hand design rules and code these rules into application logic. For example, we can create rules around age, purchase history, gender, and so on and so forth. And we'll just process the inputs based on these rules. And from there, we'll get our output. So this could definitely work when the rules are well understood and the number of data dimensions are manageable. However, since humans are involved in creating the rules here, there is a chance for error and biases being introduced into the rules. Also, rules can become complex and large, and they're consistently changing. So then this rule-based approach, it starts to have some serious limitations. Peter?
Yeah, and when we talk about those limitations, the first problem is scalability. It'd be extremely difficult to anticipate and identify all the rules and code them all into the application. The second problem's adaptability. When there are new data and situations, the old rules just don't work. You'll need to hand design new rules or modify the existing ones. And the third problem is that those hand designed rules assume we've got a complete understanding of all situations, which we know isn't always possible.
Yeah, absolutely. So this obviously it requires then a different approach. And this approach is using machine learning. So you would take all of your data, so or your historical purchase history and create a model from there. And your model has these rules built in. So from there, you would take your most recent purchase because you want to teach it somehow. And your output would then be your recommendations or your predictions.
Right. So instead of giving the computer a strict set of instructions,
Mhm.
you're giving it enough examples so it can learn to make really good guesses.
Yes. And by allowing machine algorithms to sift through our data, sort and separate tech trends and find anomalies, the differences will be almost immediate. So the process immediately becomes scalable because rules can automatically adapt to new types of data, new situations, and none of it will be designed by hand. So machine learning is not just about predictions. It's extremely useful for tech trends, for forecasting, and it can help greatly with technical anomalies. So these anomalies could be bad, so with fraud detection, or maybe they could be good, like learning that, for example, people between the ages of 20 and 25 tend to buy a specific item on a specific day. So we'll know then to either highlight this item or to maybe arrange a sale in advance. And this actually leads us to the next section where we've seen, the what and the why. What about the when? Okay, just to sneak this in here. At Amazon, we use machine learning at scale and on a daily basis. Throughout our fulfillment process, including developing a forecast system that can predict the appropriate amount of demand for each product we sell so that we can deliver on our customer expectation and in delivery speed. We've also developed natural language processing technology to give consumers an entirely new way to interact with technology. That's through Alexa. We've also developed groundbreaking technology with autonomous flight via prime air drones. And again, all of this is something that every organization can do and should do. And we bring these learnings into the services that we offer to customers.
Yes, so ML can be applied to many different common challenges across various business functions and across different industry verticals. Here are just some examples of where we've seen our customers succeed. If we take a couple of these, fraud detection, for example, machine learning can be used to identify anomalies in credit card activity. It can also be used for financial forecasting. So, estimating future financial outcomes for a company, a project, or for capital budgeting. And of course, sentiment analysis, which we're going to talk about some more. That would be reading the sentiment of customer comments.
And to bring AWS into the conversation again, AWS has quite a few easy to use AI services to tackle these common use cases with no prior machine learning experience required.
Yeah, absolutely. And in fact, I have a great example with our computer vision modeling service, Amazon
Mhm.
Recognition. You can read more about this example on the AWS case studies page. But in 2017, a South African bank by the name of ABSA needed to go through a rebranding exercise. They looked at their content, the artifacts they had, and they identified around 48,000 pieces of content which needed to be analyzed and possibly changed. They estimated it would take 8 months to completely just do one review cycle if they did it manually.
Okay.
But luckily, they didn't do it manually.
Yeah.
They worked with one of our advanced consulting partners to train recognition using the Amazon SageMaker service to identify the old logos and content. It took just 3 hours to complete an entire review cycle, and they estimated their savings at around half a million US dollars.
Wow. Okay. But I think, Peter, This does not mean that we should use machine learning for all the problems, right?
Correct. Machine learning might not be the right approach for everything. Some situations where we think machine learning should be considered, for example, would be if you cannot create and code the rules to make a decision.
So, for example, if you want to recognize image and speech, there's no easy way to code the logic to achieve that.
Yeah. And another example is where you need human expertise for decision making, but the volume is just too large for a human to do it efficiently.
So, for something like spam detection, while a human can do it, the amount of data volume would make it impractical to do it manually.
Yeah, two more situations where machine learning is ideal. If you need to adapt and personalize content based on individual data, like individualized product recommendations or website personalization. And lastly, if you can't track the information fast enough to make a rule-based decision. So automated driving, where so much of the data is coming from thousands of sensors at one time, ML would react to it much quicker than a human could.
Okay, so let's go beyond use cases and then ask the question, how does one get to implement any of these type of workloads? So how do you get from gathering data to understanding the data to then creating the model? And to answer that, let's look at the machine learning process from start to end. So starting with the business problem, you will spend some time with that and converting that into a machine learning problem. You'll need to frame the core machine learning problems in terms of what is observed and what answer you want to make the model predict. After that, you want to get all of your data together and pre-process that because you'll use this to train your model. So this includes cleaning your data, preparing it to make it suitable for consumption by your machine learning model training algorithms. You're also going to want to visualize and analyze the data to run sanity checks, to validate the quality of the data and to understand the data. Finally, you'd feed the data to the learning algorithm to build models and evaluate the quality of the model. So you'll tweak it based on how it's doing, if you like its performance or not. You might do some feature engineering, you might tweak some hyperparameters, and eventually deploy that model, and it starts to make predictions in your own environment. Then at some stage, you're going to retrain it and repeat the process.
If we look at retraining a model for a minute, why we would do something like that, if we go back to the example around classical programming and setting up rules, the same way you'd want your software apps to be up to date and current, you'd want the same thing for your model. So with software you write rules to follow. With machine learning, your model figures out the rules based on the data it's trained on. So in order for it to stay current, it needs to be retrained on current data.
Yes, exactly. And doing all of this manually, it can be complicated. It would require a large amount of data, also individuals with a vast amount of experience, and of course, time. So, what I want to go over quickly is how these phases and how steps within this pipeline can be implemented with AWS services, and then to also understand how you can implement AWS machine learning services specifically without having to go through each and every one of these steps. Okay, so as I said, the first step in machine learning is to decide what you want to predict, which is known as the label or the target answer. Do you want to predict the number of purchases your customers will make for each product? In which case, the target is numeric and you're solving a regression problem. Or do you want to predict which products will get more than 10 purchases? In which case, the target is binary and you're solving a binary classification problem. So it's important to also avoid overcomplicating the problem and to just frame the simplest solution that meets your needs. Then in the next phase, the data collection and data preparation phase. So ML problems, they start with data, preferably lots of data for which you already know the target answer. So often data is not readily available in a labeled form. So collecting and preparing the variables and the target, that can be one of the most important steps in solving a machine learning problem. AWS provides a number of ways to ingest data from different sources. You can build a data lake using Amazon S3. To easily set up a data lake, you can make use of AWS Lake Formation. Of course, there's several services you can use for ETL. AWS Glue is a fully managed ETL service. Then there's data visualization and analytics. So in this phase, we have tools like Amazon QuickSight. It is a cloud powered BI service that provides dashboards and visualizations. It has built-in machine learning capabilities, and we'll actually cover this in detail in some more data in tomorrow's session. So if that's something that you're interested in, then do join us there. Then, of course, we have Amazon SageMaker, which we are going to keep bringing up throughout the machine learning pipeline. So Amazon SageMaker is a fully managed service that encompasses the entire machine learning workflow, including labeling, preparing your data, and going through to making predictions. Okay, in the next phase, we talk about feature engineering and model training. Here you select a machine learning algorithm that's appropriate for your problem, then you train your model. And again, Amazon SageMaker provides several popular built-in algorithms that can be trained with the training data that you prepared and stored in Amazon S3. You can also bring your custom algorithms to be trained. SageMaker also enables automatic model tuning. Then in the last phase, deployment and debugging. So of course, SageMaker offers a broad variety of options for deployment and inference. So as we said earlier, it can seem complicated. The good news is that our AWS machine learning services are available to help along this process. As you may already know, we offer builders the right tools for the right job at AWS, and we provide them with choices. And the same applies to, when it comes to AI and ML. AWS offers a broad and deep set of services and the supporting cloud infrastructure for AI and ML services. Okay, so all of this put together is the machine learning stack, which we'll see here. And yes, so I think I've been talking too much. So I'm going to hand over to Peter now, who's going to take us through this view of the AWS machine learning stack in detail, and then maybe throw in some demos.
Great, thanks. The ML stack consists of 3 layers, and at each layer of the stack, we're removing the undifferentiated heavy lifting so customers can move faster. And the point I want to make is that as you go higher in the stack, you don't need to be an expert and data scientist to make use of these services. At the bottom layer, we are at a very technical layer here. So you would boot up a powerful virtual machine, and then you'd install your ML frameworks, and then go through the process of the ML pipeline, data collection, data preparation, building your model, training your model, and deploying your model. Within this layer are the frameworks, interfaces, and infrastructure for expert ML practitioners. At the frameworks layer, there's TensorFlow, PyTorch, and MXNet. We won't go into this layer in too much detail, just to let you know that it's there. And in fact, AWS provides the broadest and deepest portfolio of ML infrastructure services with, as Alpana said earlier, in terms of choices of processors and accelerators. But again, this layer is for your expert ML practitioners. There aren't many of them around. So if we want ML to be pervasive, we have to make it easier for the everyday developers and data scientists to build, train, and tune ML models. And that's what the middle layer of the stack is for. In this stack, we have managed services and resources for machine learning for developers and data scientists. These types of services enable you to label data, build, train, and deploy and operate custom ML models without having to worry about the underlying infrastructure needs. Again, the heavy lifting of infrastructure management is managed by AWS, so that your data science teams can focus on what they do best. In AWS, this service is called Amazon SageMaker. We introduced it back in 2017. It's the service that makes it much easier to build, train, and deploy ML models for every step of the pipeline Alpana described above. SageMaker puts machine learning within reach of a much broader audience. Customers jumped onto the service. In fact, they flooded us with new product feature requests, which, if you've seen the last reInvent, we're constantly building and improving on. All of these features and tools within SageMaker are wrapped together in the first comprehensive ML integrated development environment called SageMaker Studio. Through Amazon SageMaker Studio, we've brought all the ML capabilities together in a single pane of glass so that you can get access to all your tools, from data prep to bias detection, to shared notebooks, to model monitoring, to the first CI/CD services for machine learning, making that accessible to every developer and data scientist in one place.
So Peter, let's actually have a quick look at SageMaker and SageMaker Studio on the console. So I'm just going to take over a bit here.
Cool.
Okay, so this is the console. So, the landing page for Amazon SageMaker. And if we just have a look down here at the dashboard, um, this just it gives us an idea of the tools and the features of SageMaker, for the different phases of the machine learning pipeline. So, for example, in the build phase, we have Amazon SageMaker's Jumpstart. So Jumpstart is a capability that accelerates workflows with one-click access to popular model collections. And then also for training models, we have, we mentioned automatic model tuning. And then on the deploy side, there's one-click deployment on SageMaker. So we talked a bit around SageMaker Studio. This is the AWS machine learning IDE. It can be launched pretty easily. I'll show you how. So up here, if you just click on Open SageMaker Studio, and there's two options to start it. You can run the quick start, or obviously the standard setup where you'd set the configurations. But if we just run this quick start, we'll set a username and we'll choose an IAM role. So this is for IAM permissions. I've already created one called My SageMaker role. We'll hit submit, and then we'll choose the VPC that we want to run it in. So this is just the location of where it's running. And save and continue. Okay, so that's then launching. This takes about 5, maybe 10 minutes to run, but I do have another one that I've started up in a different region. So we're in the Ohio region. So this is what it will look like once your SageMaker Studio is up and running. You'll have your list of users here, obviously with different permissions or privileges, however you want to set it. And then to open Studio, we'll just go over here and click Open Studio. Okay, so now Jupyter Notebooks. So this is an open source web application for data scientists. It's used to create and share documents with code and visualizations, etc. So your Jupyter Notebook and your Jupyter lab environments, they're launched automatically through SageMaker Studio. If you have used a Jupyter Notebook before, you'd know that it needs a computing environment to run on. So what's actually happening here is that SageMaker provides the fully managed servers in the cloud to make this easier for data scientists or developers. And this is what we're looking at here. This is a fully managed Jupyter lab. So your Jupyter Notebook, if we just open one up here. So, it contains rich text. It can be markdown format, of course, code. It depends on the kernel that you select. So your notebook kernel up here, it's a computational engine that executes the code that's contained in your notebook document. So there are, as you've seen, there's a couple of prerequisites that you do need to do, but as you can see, it's made for developers. At this stage, we don't know anything about the infrastructure that we're running on. We don't know what it's running underneath. We just type in the code and we run it. And now that we're here, what I would like to demo is how, as a developer or as a data scientist, you can build, train, and deploy machine learning models in minutes. Okay, let me just switch to a full screen so we get a better view of this. Now, we have spoken about how taking machine learning models from conceptualization to production can be complex and time-consuming, and how Amazon SageMaker reduces this complexity by making it much easier to build and deploy machine learning models. So what I want to demonstrate now is how, with just a couple of lines of code, we can prepare data, we can train a model to learn from data, we can then deploy the model, and we can evaluate the model's performance. So I'm going to walk through this at a very high level, so don't be too concerned with the code. I just want to demonstrate how a machine learning developer or a data scientist would do something like this. So let's assume that I am a machine learning developer working at a bank, for example. And let's say that I want to predict the likelihood of whether a customer will enroll for a savings account or not. So 2 things. First, we're going to use the XGBoost machine learning algorithm. So XGBoost is an open source implementation of the gradient boosted trees algorithm. Gradient boosting is a supervised learning algorithm. And what it does is predict a target variable by combining the estimates of some simpler models. Second, we're going to train the model on a bank marketing data set. It contains some information on customer demographics. I'll show you what that looks like. So there's just information around age, job, education, etc. And then the output variable is, has the client subscribed to a term deposit or a savings account? And it's available, publicly available from University of California. Okay, let's get back to the start. So I already have a notebook opened here. And to start phase one, preparing our data. So the first thing that we need to do is just import some libraries and then define some environmental variables that we would need. So to run this block of code, we'll just click the run button and the star turns to a number. And then there's the output there. Okay. Now we create the S3 bucket that's going to store our data, and we'll download the data into our SageMaker instance. So that's the bucket that I've created earlier. Okay. Now that we have the data, we're going to shuffle and split the data into training data and test data. So this is standard procedure when preparing data for models. The training data is about 70% of customer data, and it's used during the model training loop. Then the test data, this is the remaining 30%. It's used to evaluate the performance of the model and measure how well the trained model actually works. Okay, and that's phase one. So we've prepped our data. Now in phase two, we want to train our data. So we're going to use our training data set to train our machine learning model. This code, it does some reformatting of the training data, and then it loads the data from the S3 bucket. Okay, we now set up the Amazon SageMaker session. And what this does is it creates an instance of the XGBoost model and it defines the model's hyperparameters. Okay, and the final step to train the model, we'll simply start the job. So this code, it trains the model using gradient optimization on a MLM4X large instance. And once we've trained it, we'll deploy it to make predictions and then evaluate it. Okay, so it does take a couple of minutes to run, and I actually ran it a couple of minutes ago, and this is what the output would look like. So it's trained the model. Okay, so finally, we can, of course, evaluate the model, and we can compare the actual versus the predicted values in a table that's called the confusion matrix. So that's what the output here will be. And based on the prediction, so we can conclude that we predicted a customer will apply for a savings account accurately for 90% of the customers in the test data, with a precision of 65% for applications and 90% otherwise. So again, this is not to overwhelm anyone. It just demonstrates the ease of getting started on SageMaker. As a data scientist or as a developer, after you choose the right algorithms and frameworks from the range of choices available, SageMaker manages all of the underlying infrastructure to train your model at petabyte scale and then to deploy to production. Okay, to conclude this section around SageMaker and SageMaker notebooks, there are tons of GitHub repositories that are available to play around with and to experiment with all sorts of SageMaker notebooks and different machine learning models. So you can just simply clone a GitHub repository from here. That's a common SageMaker repository. And that's that.
Awesome. Thanks, Alpana. I'm not much of a developer myself, but if we put aside the coding aspect and machine learning algorithms, I can definitely see how easy it is to get started with SageMaker. And on that, moving on to the final stack, the most interesting stack, in my opinion, is our AI services. These are accessible through a simple API call without any machine learning skills and without any coding or Python skills. Here we serve developers who want to add solution-oriented intelligence to their applications through an API call, rather than developing and training your own models in SageMaker. And we have a lot of services in this area to address your needs, including industry-specific services. Our vision services, Amazon Recognition, image and video, let you ask it what is in this image, what celebrities do you want to see, is it safe for work? With speech services, you can turn text into speech with Polly, not to mention Alexa, which I think you'll agree is what Amazon is pretty famous for. We have chatbots with Lex. You can also turn audio into text with Transcribe. We have our personalization and forecasting service. And in the contact center space, we have Contact Lens for Amazon Connect. This provides machine learning powered analytics as well as Voice ID, which is machine learning based caller authentication.
So these are all AWS pre-trained services that can add intelligence for your existing applications and workflows. If you want your application to provide personalized recommendations or to modernize contact centers, this will bring you much closer, to what was available before. We use the same deep learning technology that powers Amazon.com and our machine learning services. So as customers, you are getting the quality and accuracy of the continuously learning APIs that we continue to improve over time. So let's switch again and talk about one of our more popular ML services, Amazon Personalize. And Peter, you're somewhat of an expert with this service, right?
Yeah, and with Personalize, we aim to give you an out-of-the-box solution to foundational use cases for personalization. You can use these capabilities for generating a broad array of personalized user experiences. And in fact, I have a session coming up. Just keep an eye out for that in a couple of days. But let me rather show you some of my other favorite services before then. Let me just switch across to the console and we'll jump right into it. Great, always fun to be in the console. So what I'm going to do is jump across to services, machine learning, and we can find comprehend. This is the first thing I want to show you. I just want to give you a sense that in the console for these services, there are more often than not examples that you can use to fiddle with, to play with, and to see how the service works. Comprehend's no different. If I click on Launch Amazon Comprehend, just before I do that, I guess I should point out that Comprehend, the purpose of it is that it's a managed service to analyze, to derive insights from, identify relationships and important information in unstructured text. You'll see what I mean about that in a moment. So let's click on Launch Amazon Comprehend. And as I said, it comes with an example. We can see this example text. It's basically stating that this account number has a minimum payment due by that date and has a bit of potentially sensitive information in it. So what we're going to do is click on Analyze. And the first thing I can show you that Comprehend does is identify a number of entities in that text, which it then categorizes. We can see here that it's identified this field here as date, this amount as a quantity, this text as a person, which is pretty impressive. If we click on key phrases, again, it's identified a number of series of text as a particular phrase. Under language, we can see that there is a Comprehend has a 99% confidence that this is English. And then this gets really interesting. So what Amazon Comprehend is doing is it's identifying a number of fields as personally identifiable information. This is super important in case you need to know whether you need to limit access to this data, you possibly need to encrypt this data, maybe this gives you a sense that you need to anonymize this data. So we can see that it's identified these entities as having a very high confidence rating, that is personally identifiable information, which it quite obviously is. Then lastly, sentiment, it's telling us that this is a pretty neutral text statement, 0% positive, and maybe that 1%, 0.1, what is 1% negative is due to the fact that there's a payment due. Then lastly, it's identified a number of elements of syntax in that text. I just wanted to show you this to see what you can do and test and kind of work with in the console in terms of the predefined examples. I'm going to jump across to SageMaker and open up a notebook that I've set up to show you more of a real world example, and also to give you a sense of how you might interact with the service through the API, through the Python SDK. So let's open up our Jupyter notebook. So we're going to start with Comprehend Medical demo. So Comprehend Medical is specifically focused at medical text and phrases, that sort of thing. And so how we interact with it is, you can see that there's a code snippet here in this Jupyter notebook. And the first thing it does is import a number of required libraries. Photo 3 is the AWS SDK. It's importing pandas, amongst other things. So let's run this code snippet. Right, we've imported all the necessary libraries. Now what we're going to do is, you can see that there's a chest x-ray PNG file here. We're going to load that chest x-ray and display it. Right, here's the x-ray. You can see that there's a bunch of information and text on this x-ray image. So what we're going to do now is we're going to use the Amazon Recognition service. And Amazon Recognition is basically a kind of visual service to detect and identify elements in an image. So let's click on that code snippet and run that. What it's also done, you can see, is it's returned the text. It's also aggregated the text into a single block, and we are keeping track of the offsets, so we know where the text and details are. What we're going to do now is we're going to call the comprehend service. We can see here this text, we're calling comprehend detect, and that's detecting the personal health information. So let's run this code snippet. Immediately, comprehend has come back and identified this as an ID, redacted, date redacted, name redacted. And then what we can do is we can then generate masking to mask that image with red boxes to hide that redacted information. So I'm going to click on that. And now we can see we have the x-ray returned, the personally identifiable information has been redacted, and it is, this can now, you've effectively anonymized this x-ray, right? So that's pretty neat. That's using comprehend comprehend medical and recognition to do that piece of work. And I thought that was a pretty neat real world example. If I go back to the console, I'll just show you a couple more examples of what you can do. So let's look at translate quickly. So translate, I'm sure you've all seen something like this to one extent or another. Here we can type in, we want. I expect that translate will effectively and speedily to language I so desire, exclamation. So we can pick Estonian, we can pick Gujarati, did I pronounce that right? We can pick Hindi, Arabic, Afrikaans. So that's pretty cool. And much the same as you saw me interact with comprehend using this Python code, You can do the same with Amazon Translate. You can use the AWS CLI to interact with Amazon Translate, and there are additional services that you can leverage, additional functionality, I should say. You can see here that there's custom terminology. So what you can do with custom terminology is you can translate maybe a brand name from English to another language, and then insert that as custom text. So you might want something that says the word fresh in Afrikaans or says the word fresh in Estonian. And so you'd add that as part of your brand name to custom terms. And then when that particular brand name came up in English, for example, it would accurately translate that as a custom term into whatever target language you wanted it to. Then the other thing I thought was pretty cool is to just show you Textrax quick. So as the name implies, you can automatically extract handwriting, text, or data from any document using machine learning. So this is a fully managed service using machine learning. And so I've got a couple examples to show you. The first one is the form that comes with Textrax as an example. We can see here a standard sample document. I think the neat things to point out is that it can identify from the sample document the raw text. It can identify a number of different forms. It can translate this table into an actual table, and then you can download the results of that. I'll show you a couple little examples that I've come up with. So I created a fake little vet appointment sheet. It's taking a moment to upload the PDF to the S3 bucket, and then it's going to analyze out of the S3 bucket. So let's just give it a moment. And here we go. So it's identified name of owner. It's identified a whole number of different fields in terms of raw text. If we go to forms, it's picked up name of owner. So that's a form field, name of pet, breed of pet. It's identified that this gender radio button has been selected, male selected, age, time. If we go into tables, there aren't any tables here. And what you can do is you can also include a human worker to review documents with particularly sensitive text or very nuanced content. So you can add that. Here's another real world example I'll pull up briefly, is my vet bill. So this is an actual invoice I got from a vet a while ago. I've taken a bit of information out of it. And we'll see how Textrax is able to interpret this. Again, Textrax pulled up a whole bunch of information. If I click on forms, we can see, much like the previous example I used, it's identified a number of forms. And if we click on tables, now we can see that the main kind of itemized bill, it's identified as a table. So I thought that was pretty cool. And that is it for this little demo. That's all I wanted to kind of show you in terms of some of these AI services. And as mentioned, I will be demonstrating Personalize in a bit more depth. That's one of the other services here under machine learning. You can see Personalize right here. That's me.
Okay, that was pretty cool, Peter. I'm also amazed at, how easy it is, firstly, to just get started, and then just how accessible it all is. So before we close off, there's just one more thing that I want to talk about, and it is potential next steps in your machine learning journey.
So for accelerating machine learning adoption, AWS has a number of acceleration programs and trainings to help you get started on your journey. We can conduct workshops to help you identify the best use cases for your business and work hand in hand with your team to develop a proof of concept through the ML Solutions Lab. And through our AWS ML Embark program, we do in-person training for both business decision makers and technical staff. We do ideation on use cases, development of proof of concepts. And lastly, we have professional services team as well as ML partners who can do end-to-end development and take your machine learning application to production.
And of course, in parallel, you want to focus on building the right skills for your engineers. At Amazon, we developed a machine learning university that we have used for over 6 years to train our engineers on machine learning. And last year, we made a lot of this content available for free for our customers. I would also suggest that you have a look at this link. This is a great blog post for building your machine learning skill set for today's rising demand. The article is ideal for those new to machine learning, who want to understand the foundational skills needed, as well as those who want to deepen their machine learning knowledge and expertise. You'll find in the article links and suggestions to AWS training, resources, and documentation to help you move along.
And that brings us to the end of our webinar. Thank you so much for your time today to learn how AWS can help you modernize your machine learning environments. If your ML team can benefit from any of these offerings as next steps, we'd like to recommend an ML discovery session with our machine learning specialist and machine learning solution architect. That would help us understand your current machine learning work streams and your drivers for modernization. We could follow that up with a number of different deep dives on various services or potential workshops. It would be really great to connect your team with our AI and machine learning specialists and architects to accelerate your ML journey. And as always, we'll stay online to answer any questions you may have. And thank you once again.
Thank you. Bye.